All right, we are in Chapter 1, Lesson 4 for Math 8. And we are going to be looking at powers of monomials. So we're looking at some more power rules here. So let's go ahead and get started here. We've had this a few times with the last section. We're ready to fill in the blanks here. Let me grab my pen tool. So I have it here. So we have blank, 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 blank. So 4 blanks in this case, is to multiply the exponents. So multiply, a lot of the time, when we hear multiply, we're going to use the word product. Exponents means that we're going to have the word power in there. So we just have to put these together. We have power of a product. Product. And we had, in the previous one, we have product of power. Now this is power of a product. They are different. So product of a power means that I'm multiplying two things with the same base. So I would have a squared times, a cubed. So I have the same base, and I'm multiplying them, and I add the exponent. That's product of a power, what we did previously. Now that we have power of a product, we have to look at it differently. So that means that we have a base and an exponent, and then we have another exponent outside of the parenthesis. That's what this looks like. So if we were to expand it out, what it means is I have 5 of this piece inside the parenthesis. So there's 6 to the 4th power, 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 6 to the 4th power. There's 5 of them. Remember, each one of these has 4 6s in it. So now that we've expanded it, this looks like product of power, meaning that we have the base of 6, 6, 6. They're all the same base. We can add those exponents together. So 4 plus 4 plus 4 plus 4 plus 4, which is showing right here. And we can just say 6 to the 20th. So if I were to expand this out and write out all these 6s, there would be 20 of them. That definitely starts to get a little tedious. We don't want to have to keep expanding when we get to this point because it starts to get a little too time consuming and just a little boring to write out that many, honestly. So we're going to go ahead and take a look at some of these down here. And it says whenever in doubt, expand it out. And this is partially expanded. So you don't necessarily have to expand the whole thing, but, expanding part of it definitely is helpful. So this is 2 to the 5th power, and then we're raising that 2 times. So we want 2 of these pieces. Okay? So 2 to the 5th power, 2 to the 5th power. So now I have the same base, 2 and 2, and I can say 5 plus 5, and that gets me 10. So is there a faster way to do this without having to write it out, without having to expand it? Of course there is. So I just wanted to make sure we went over that idea. But if I go back to this example here really quick, what's 4 times 5? It's 20. So this is another way that we can do this a little quickly. If we have this situation here, whoops, didn't mean to undo that, where we have exponents that they almost kind of look like they're touching here, with the exception of the parentheses. They're just exponent, exponent. We can multiply them to simplify a little faster. So same thing here. I can go 5 times 2 and I get 10, which is exactly what we got here. So it's just a little faster way to do that. So it's the power of a product rule. We can multiply the exponents. Instead of adding them, you add them if you've expanded it like this. But if you haven't expanded them yet, you can multiply them. So this case, we can go 4 times 6, and we would get W to the 24th. So if I were to expand this, remember this means W to the 4th 6 times. W to the 4th, W to the 4th. It's 1, 2, 3, 4. And 1, 2, 3, 4, 5, 6. So I have 4 plus 4 plus 4 plus 4 plus 4 plus 4. It's one more 4 than we had up here in the example. So it's 24 of them. So it still gives us the same answer. It just depends on how we like to view that. If you want to expand it out each time, definitely encourage you to do that if that's how you like to see it. But kind of a quick option here is to multiply. Okay, so now we have kind of a funny thing, and I want to take a look at this one because we have an extra set of parentheses. So we have our regular parentheses in here, the kind of curved ones, and then we have brackets, meaning that it's 2 layers of parentheses. They're both parentheses. They're both grouping. They're showing us the first layer and the second layer with the brackets. So with this one, we have a couple power of product happening. So 3 squared to the 3rd power is happening 2 times. So I'd go 3 squared to the power of 3 and 3 squared to the power of 3. So here's 2 of them. That dealt with that exponent. Okay? But now I have to deal with it's happening again. So I have 3 squared, 3 squared, 3 squared. So this is the first bracket. Here's 3 squared happening 3 times. Now it's going to happen again. 3 squared, 3 squared, and 3 squared. So I just want to make sure we see this expanded out so I can see now I have all bases of 3, and I can just add 2 plus 2 plus 2 is 8, plus 2 plus 2 plus 2 is 16. So I'd have 3 to the 16th power. And we need to be a little bit more careful with this one. Let's see, did I do that right? Oops, I added too many. Haha, I did times when I was doing that. 2 plus 2 plus 2 is not 8, it is 6, plus another 6 is 12. Ha ha ha. That was silly of me. Multiplying in my head instead of adding. So 3 to the 12th power. So could I have done the same multiplication trick that I did over here? Yes, of course I could. I'd go 2 times 3 and I'd get 6 times 2 and I'd get 12. So I still get that 12. I can still do that same multiplication rule. As long as it's exponent, 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 if there's no other bases or anything like that thrown in. So I just have to make sure that's what it looks like. All right, let's practice a couple more of these and we'll go to the next page here. So with this one, I'm just going to go ahead and do that quick option. 2 times 3 is 6. So it's 4 to the 6th power. And if you actually wanted to do this on a calculator, because they may ask you to simplify even further. So I want to make sure it was 4, right? Yep. Losing my train of thought here. I was almost going to do 2. So 4, and I don't have to the 6th power here. I could do 4 times 4 times 4 times 4 times 4. I think that was 6 of them that I said out loud right now. But I could also use this little tool here, which is x, y. So x is the number I type in. That's my base. So in this case, it's 4. And I have an exponent of 6, which is y. So I need to type in my base first, and then I can click this button, and then I can tell it what my exponent is. In this case, it's going to be 6. It's going to equal 4,096. So I can go back to here, and I could write 4,096. Because we're practicing powers, they might want us to leave it 4 to the 6th power to show that we need to combine those. But 4,096 is also an answer. All right, so now this one we have 3 times 3, so we get to the 9th power. So 5 to the 9th. I'm going to go ahead and leave it 5 to the 9th on that one. All right, so let's look at the second page here. So this is still lesson 4. So now we have, is this the same one? I want to make sure that's not the same page. No, it's not the same page. Okay. So now we have still powers of monomials. We have blank, 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 blank is define the power of each factor and multiply. So it's still the exact same rule. We're actually still practicing power of a product. We're still doing the exact same thing. Oh, I mixed my C and my T together. The same thing we were doing on the last page. The only difference is now they want us to solve it. So they do want us to go through and get this end answer here. So they don't want us to just leave it as 234 or 3 to the 5th and then a squared 5. They want us to actually multiply this out and give them the end answer. So with this one we have 8. And remember, now that we have more than one thing in this parenthesis, we have to distribute this 2 to all the pieces. So the 8 is being squared just like the b to the 9th power is being squared, okay? So 8 squared is 64. So 8 times 8 is 64. And then I can do 9 times 2, and I get 18. So that is the answer for that guy, just 64, b to the 18th power. Just make sure you're applying that exponent to everything in the parentheses, so every single piece. So now I have 6 to the 4th power. So if we use that little tool on our calculator, I can go 6 to the 4th power. And remember, you have to use that XY feature because none of the calculators are going to have to the 4th power. Or you could say 6 times 6 times 6 times 6 in your calculator. You will get the same answer. So you'll get 1,296. And then you have 5 times 4. And then for y, you have 11 times 4. So 44. So these definitely would start to get very tedious to write out all of these pieces. We're starting to get much bigger numbers. All right, so let's keep going here. So we have -5 raised to the 3rd power. So it's -5 times -5 times -5. So when you do this on a calculator, I want to make sure if you type in 5, and then you could either hit the cubed if you have it. If you don't, you hit the little XY button and then 3. But we had -5, so we need to be careful. We want to do 5 and then find this little swap button. It might have little arrows going back and forth or something like that, or it might just look like this on your phone. You hit this button and now it's -5. And I can either hit the cubed button or this button in 3. So I'm going to go ahead and hit the cube button. Why not? I already have that feature on here. It's built in. So it's -125. So just be careful about that negative. We want to make sure we apply it correctly. And then we have 2 times 3 for W. And then we have 8 times 3 for Z. So that's 24. All right, oops. Why is it not letting me zoom? Interesting. It's not letting me zoom out. All right, well, hopefully that's not too blurry here. I believe that is a J. So we have 5 to the 5th power. So you're going to have to use that XY button if you do it, or do 5 times 5 times 5 times 5. So we end up with 625 for 5 to the 4th power, and then we have 6 times 4 for J. All right, now we have 11 to the 3rd power. Again, you may have that cubed button. You're welcome to press that, or you can use the XY, or you can do 11 times 11 times 11. You get 1,333. And then for C, we have 4 times 3, and we get 12. All right, couple more here. So we have 7x to the raised to the 3rd power equals 7 to the 15. They want to tell us what is x. So if I know x times 3, remember that's our rule, we multiply these, and that gave me a result of the 15. I'm only looking at the exponents here. So I know x times 3 gives me 15. Well, what does x need to be? X needs to be 5, right? In order to get me 15. So x has to equal 5. And if I'm looking at this one here, so now we have this x on the outside. And they want to know, well, what does it need to be in order to get this answer here? So I have -8, and I started with -2. And remember, I'm multiplying -2 times itself until I get 8. So 2 times 2 is 4, times 2 is 8, so I have 3 of those. So I know I had to raise this to an exponent of 3. So if I test that really quick and I look at m, I started with cube, I started with a 3, and now I have 9. Well, if this was a 3 on the outside, like I'm proposing for the 2's, 3 times 3 is 9. And with this one, if I 4, and this was a 3, 4 times 3 is 12. So that does work. In this case, x would need to be 3. So when it's asking you questions like this, it just wants you to kind of pay attention or kind of think through, what does my missing number need to be in order to get this one? And this is just using the power rule a little differently. I wonder if I minimize. I wonder why it's doing that. That's interesting. It changed my my toolbar here. So now I'll need to figure out how do I... Well, I'll need to figure that out for the next video. So that is lesson 4, and I will see you in lesson 5.